Well, this is assessment 4.3 review, and I forgot that I take reviews very seriously. So, yeah, let's go ahead and get started. Not unlike all my other reviews, we start out with a bit of a vocabulary dump. Not so much dump, but we start heavy with the vocabulary. Let's go ahead and go with that. So we'll go ahead and get started on that. For each expression, we're identifying the degree, leading coefficient, constant, and then type. So we'll go ahead and get started here. Uh, so for the degree, it's going to be 2 because that is the highest polynomial, that is the highest number, the highest exponent for the entire polynomial. The leading coefficient is going to be 3 because that is the coefficient that is the coefficient that is attached to the variable with the highest exponent in the polynomial. It gets a little harder explaining that term every single time. Then there's the constant term. Constant term in this case is going to be 4. That is the number or the term that doesn't have a variable attached to it. Finally, we have the type. And this one is 1, 2, 3. This one's going to be a trinomial. Alrighty, we are off to a good start. So this next one, the degree is going to be, I got a 4, 2. The degree is going to be 4 because again that's the highest exponent. The leading coefficient is going to be -5 because it's attached to the x to the 4th. The constant term, there it is going to be 6. And then the type, I've got 1, 2, 3, 4. And so because I've got 4 or more terms, I'm going to have a polynomial with, and then I have to finish it out, 4 terms. Alrighty. There we are. I can center it up in the frame like this. Okay. So 9x, the degree is going to be 1. Because even though it's just an x with a single variable, it always has an exponent up there, which is 1. So the leading coefficient of this one, that one's going to be 9. It's the only coefficient. Let's see, our constant term, that's going to be 0. Does it exist? Does it not exist? That's more of a philosophical discussion, really. And then type, this is a monomial because there is only one, because there's only one of them there. Yeah, there's only one term in this polynomial. That is why it is a monomial. All right, next, we've got the degree. All of these look like they're written in standard form, which is pretty awesome. So that means that our degree is going to be on the far left-hand side each time. But it's good to check just in case. The degree in this one is going to be 3. The leading coefficient is going to be attached to the polynomial, is attached to the number that has the high degree on it. It's going to be 1. Let's see, the constant, 1. And then the type, I see 1, 2, 3, 4. Polynomial with 4 terms. So we're doing pretty well with, still doing pretty well with that. All right, this next one, negative x squared. Well, there's only really one polynomial with a degree on it, so that's the degree is equal to 2. The leading coefficient is -1 because it's got the minus sign there. The constant is 8. And then the type, because there are 2 terms, and you always include the constant when you're counting the terms for a polynomial, is the binomial. Alrighty. For this next one, Let's see. Yep, the highest one is going to be to the fifth. So that means our degree is going to be 5. Our leading coefficient is going to be 4. The constant is going to be -7. And then the type is going to be 1, 2, 3, 4 polynomial with 4 terms again. There we go. All right. Well, this one's pretty straightforward. And I did look up what you're supposed to answer when you see these. So the degree is 0. The leading coefficient is 0. The constant is 6. And the type is technically a monomial. It's a monomial with constant 6. Or you could just call it the number 6. Like I said, Matt, there are a bunch of different ways, there are a bunch of different terminologies that you can refer to the same thing. But yeah, I just thought it was funny that I just thought it was funny that the nomenclature exists for that. So anyway, moving on. For D, the degree is x squared, so that one is 2. The leading coefficient is the one that's attached to the, one that's attached to the x squared. So that's going to be 2. Our constant does not exist. We do not have a constant in this case, so we're going to write down 0. And our type is going to be I just count 2, so that means we have a binomial. All right, we're in good shape then. Next, we have for the degree, we have I just see x to the 6th, so we've got a 6th degree. The leading coefficient is going to be -1 again, because it's just negative x to the 6th, so -1. Our constant is going to also be -1. And the type is, I think it's up to 5. So 1, 2, 3, 4, 5. Yep. Polynomial with 5 terms. All right. Yeah, that made it onto the screen. And then finally, our last one. So the degree is going to be 3. The leading coefficient is going to be the coefficient of the term that has the highest degree. There we go. That's a good way to explain it. The last review before the final assessment, which is going to be 7. Let's see. The constant is, we don't have one, so we will write that off as 0. And our type is 1, 2, 3. We've got our trinomial. There we go. So that is the first 10 questions, because I do not fool around with reviews, apparently. All right. For part B, we are simplifying our expressions, and then, yep, we are simplifying our expressions, and then writing everything in standard form. So let me see here. Oh, for crying out loud. All right. Well, at least it looks like it's in standard form. Adding it up, so yeah, it could be worse here. All right, so like I said, everything is in standard form, so it definitely could be worse. So I've got 2x squared plus x squared. That looks like it's the highest polynomial. That looks like it's the highest degree. So 2x squared and x squared, so that's 3x squared. Then I've got 3x minus 4x, so that's minus x. Then minus 5 plus 1, minus 4. And that's it. If I circle it, I think I'm going to take up too much space and it's just going to be messy. So I'm just going to leave it where it is. I don't think you all mind, because it's probably going to be my answer key. So let's see, I've got x cubed, x, and then constant. All right, all the elements are there and they're in the right order, so we can move on. 4x to the third minus 2x to the third means that we're going to have 2x to the third. minus x minus 3x, so that's minus 4x. Then 6 minus negative 2 is the same as 6 plus 2, so that's plus 8. And that's all of our terms. All right. So I've got x squared, then I've got x squared, and then I've got x and the constant. So I've got to keep track of a third x and a third constant, but for right now, I've got x squared plus 3x squared, so that's 4x squared. And then I've got 2x minus x plus x, so that just leaves me with 2x. Then I've got 3 minus 1 minus 4, so that's negative 2. All right. So even if whoever writes your quizzes is a complete jerk and throws in those little surprise terms, um, remember the operations themselves are relatively straightforward, and you don't have to let them push you around. You don't have to be intimidated by them. Just trust that you understand the process, and you'll be absolutely fine. So I've got next 5x to the fourth, 2 constant. All right. So all the terms are here, and it's written in the general form, so it makes it easier to follow. 5x to the fourth minus x to the fourth gives me 4x to the fourth. Then I've got minus 2 to the 2x squared minus x squared, so that's minus 3x squared. And then 1 minus negative 3 is the same as 1 plus 3, so plus 4. And there we go. Well, that'll do it for the review. Oh, who am I kidding? All right. Let's see. No, I needed the chuckle. All right. Let's see. Oh, here we are. Of course, why not? Let's see. I've got x cubed, x squared x, squared x. Okay, so this x squared doesn't have a match on the second paragraph, so it'll just carry over. So I've got x squared plus minus x squared. Well, I guess that's easy enough. So I've got 2x squared, and then minus x plus x. Well, that's easy too. And then plus 4 minus 2 is plus 2. All right. Well, always happy to cancel things out as necessary. So I've got 2x squared here, here, and here. All right. I've got x here, here, and here. All right. And then the constant. All right. So it's just a matter of going through and reading and being careful with the terms as I add it's addition. I'm basically adding three numbers together, but I'm adding specific numbers together, and I have to be careful about which numbers I'm adding. So 2x squared plus x squared minus 4, so that's going to be minus x squared. Okay. Negative 3 plus 1 minus 2. So that's negative 3 plus 1 is minus 2. Minus 2 is minus 4x. Like I said, I am focusing on the addition. I'm focusing on the addition side of things because that's really all I'm doing is just concentrating on the addition as a way of, well, focusing on the work and concentrating on it. Then I've got 1 minus 5, which is negative 4, plus 3, which is negative 1. And there we go. That is our answer. All right, so I've got x squared minus x squared. Well, there we go. I just took a quick look. I've got x squared minus x squared. Those are gone. 2x. Oh, wait a minute. No, 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 no. I went too fast on that one. All right. So x squared, they're definitely out. Negative 2x minus 2x is minus 4x. Then 3 minus negative 3 is the same as 3 plus 3, which is 6. Oh, man. See, this is what happens when you try to if you blaze through it, you'll make mistakes, and thankfully, you're always free to capture. You can always catch them. So I've got 3, 2, 1, and then a constant. 3, 2, 1, and then a constant. All right, and they're all in standard form, so I can just keep track of them going left to right. So 3x squared, 3x to the third plus x to the third, 4x to the third. x squared minus 2x squared, so that's minus x squared. Negative 4x plus x, so that's minus 3x. And then 2 minus 1 is plus 1. Yep, there we go. And I'm crossing them off as I go just to kind of illustrate that even though it starts bad, even though it starts ugly, as you go, you get rid of all the things that you've done. You can see the work that you've finished, and you can see all the work that's left over when you're done. So it starts out with this big whole thing, but it ended with me just saying, oh, what's 2 minus 1? Which is 1. So there we go. So I've got 1x squared, I've got another x squared, so I've got 3x squared. Okay, so I've got x squareds and constants. So, all right. So x squared plus 2x squared, that's 3x squared, plus 3x squared, so that gives me 6x squared. And then 1 minus 1, so 0 plus 5 is 5, and that's the final answer. All right. So here I am again. I've got just x's and constants, so I've got 4 minus 2, which is 2, plus 1, so that's 3x, negative 7, minus 3, so that's negative 10, minus 1, negative 11. So there we go. All right. So adding and subtracting the polynomials, as long as you, as long as you stay focused and you don't try to blaze through things too quickly, yeah, you got nothing to worry about. All right. Let's see. I've got some multiplication of polynomials. Yeah, this is doable. So first things first, I can see some perfect squares, and I can see some difference of squares. So perfect squares, I'm just going to blast through those. I've got x squared plus 10x plus 25. So that one's done. This one's going to be x squared minus 9. This one's going to be 4x squared minus, I think it's going to be 8x plus 1. Minus 2, yeah, that's 2ax, so 4. So it's going to be 2, no, this is 4, this is 4. 4x minus 1. This is going to be x to the 4th minus 1. Let's see, are there any other ones that are quick solving? Nope. Looks like the rest of them are going to be, grids or are going to be boxes or foils. Looks like boxes. Yeah, looks like all of them are going to be boxes. So, you know what? All right. So I think I've changed a few. It looks like I've changed a few things. Oh, I'm going to see how this works out because I don't want to just constantly write on the paper over and over and over again. So I mean, that's why we have dry erase to begin with, right? So that we can reuse the surface and yeah, and also have like a really cool thing to sniff every now and then. So yeah, let's take a look at what we've got. So I've got x plus 2 times x squared minus x plus 4. So yeah, let's see what we've got here. So so that gives me x squared minus x 4, and then x, and then 2. All right. Yeah, we can do that. Yeah, I can get behind this here. The board doesn't look great, but that's all right. We can work around it. Let's see. So I'm just going to use the board here, get the answers, and then copy them onto the paper, and then wipe the board and move on to the next one. So x times x squared gives me x to the 3rd. X times negative x is going to give me negative x squared. X times 4 is going to give me 4x. 2 times x squared, 2x squared. 2 times negative x, negative 2x. And then 2 times 4 will be 8. All right, so That's kind of hard to see that one there. All right, so now we're going to combine terms. So that gives me, yeah, we're going to combine terms and get the final answer. So that gives me x to the third, yeah, that's on the frame. 2x squared minus x squared is plus x squared. Minus 2x plus 4x is plus 2x plus 8. And there we go. There's your final correct answer. I just got to write it down really quickly. Plus x squared plus 2x plus 8. And I got to write it down because I'm not sure if I've mentioned this. As I'm recording these videos, I'm also building my answer key. So I don't want to... this is great. All right, so next question. I've got 3x minus 2. All right, so again, get some space here. So I've got 3x minus 2, and then x squared is x minus 5. All righty. Again, we're just going to start doing not really cross product multiplication, but we're going to go across and fill in the empty spaces as we see them. So that's 3x to the third. Then 3x times x is 3x squared. 3x times negative 5 is going to give me negative 15x. All right, negative 2 times x squared, negative 2x squared. Next, negative 2 times x, negative 2x. All right, pretty straightforward. Then finally, negative 2 times negative 5 is positive 10. Now for the benefits of this, I get to just copy over. I'm just going to write down like terms. So that's 3x to the third. I have 2x, negative 2x squared plus 3x squared, so that's plus x squared. Negative 2x minus 15x is minus 17x plus 10. And that's going to be our final answer for that one. I can't believe I didn't figure this one. I didn't think of this one earlier. Especially when I have like 3 notebook pages filled with the same kind of problem. All right. So this next one is, all right, next one. Oops. There we go. So I've got 1, 2, 3, 4. Ooh, all right. I know, right? I've got 4 terms now. So even though I've got 4 terms, the process is going to be exactly the same. If I can get it to right, that's 1. So that gives me x to the third, x squared, negative x 2. I'm going to switch markers here just to see how this looks because I want to make sure that it's showing up on the, I'm pretty sure it's showing up on camera, but I just want to be sure that it's clear or clearer and it's not as evident here. So I'm going to go back to my staple. So I've got x to the third times x. That's going to give me x to the fourth. Oh, that's lovely. Okay. So that's going to give me x to the fourth. X times x squared is going to give me x to the third. X times negative x is negative x squared. Then x times 2 is 2x. Alrighty. With these, it's just going to be a trivial operation because all I'm doing is switching signs. So negative x third, negative x squared, x minus 2. All right. Now all I have to do is combine all the like terms. Gives me x to the 4. These x to the third cancels out. Minus 2x squared. X and 2x become 3x, and then minus 2. All right. So may have lost an x cubed, but we got everything else here. So it's x to the fourth minus 2x squared plus 3x minus 2. Alrighty. And we'll, okay. Let's see. Alrighty. Next, we've got, okay, and then this one's only going to have 3 terms. Not as exciting as 4 terms, I grant you. But, you know, I mean, you got to 2x squared minus 3x, and then 1, and then x, and then 4. All right. Not as exciting, I'll grant you, but yeah, we're still doing all right. So x times 2x squared, that's just going to give me 2x to the third. Negative 3x times x, negative 3x squared, and then x, I'm just going to go ahead and fill that one in. 4 times 2x squared is just 8x squared, and then 4 times negative 3x squared, that's just minus 12x squared. No, 12x. There we go. All right. Now, as ever, just combine like terms. That gives me 2x squared. Let's see, 8 minus 3 is going to be 2x to the third plus 5x squared. Negative 12 plus x, so that's minus 11x plus 4. Alrighty, put the cap on that while I write this down. Let's see, 2x to the third is 5x squared minus 11x plus 4. Alrighty, and we are moving on up. Okay. Next, for 29, we've got x squared plus 2x plus 1 times x minus 1. So the order is flipped around, but it really doesn't matter. I'm still going to draw the grid the same way. They thought that by switching the order around that it'd throw me off, but no. That's not how I do that. That's not how I do things. As I've done a couple of times in some previous videos, I'm going to invoke the triviality rule, which is that if the calculations are so trivial that they're almost intuitive, I'm just not going to do the math or even call them out. In this case, all I'm doing is adding 1x to everything, and then for this one, and then for the second one, all I'm doing is flipping the sign. So I'm just going to fill in the table, not really talk about the math behind it or walk through it very quick or walk through it. So, um, all right. Now I'm going to combine all the like terms. Gives me x to the third. Yep. Okay. Yeah, like I said, they're not all challenging problems. They just look intimidating, you know? So that gives me x to the third plus x squared minus x minus 1. Alrighty. Last problem in this section. And then we move on to the next section. We move on to the next 10 problems. Uh, I love my reviews. You will be longing for the assessment after one of my reviews. So again, we're going to be doing, we're going to be setting up a grid here. You will want, it's like I'll give you one of my reviews, and you will beg. It's like, and you will beg for the summative after like the first, not even before you've taken the first formative. Just be like, I've done so many problems, I'm done. Just get me out of this unit. Alrighty. So I've got x times x squared gives me x to the third wait, what? Oh, 2x. There we go. I knew I forgot something. X times 2x is going to be 2x squared, and then 4x. Next, I've got minus 2x squared. Negative 2 times 2x is minus 4x. And then finally, negative 2 times 4 is going to be negative 8. Alrighty, so back to our like terms phase. So that gives us x to the third. These two cancel out, minus 8. Well, ending kind of ending on a bang, so to speak, with the simple with the uncomplicated answer of x to the third minus 8. All right, so I'm going to shelve this here, and thank you very much for your service, little fella. It was great working with you, and that's going to be part A, B, and C of the review. But don't worry, we've got D and E, and yeah, we've got D and E. So don't worry, we still have stuff to do. Alrighty. So I'm going to adjust this here. Well, he served us well. Now we're going to move on to, oh, wait a second. I've got to get this recentered on the camera so that you can actually see what's happening on this. There we go. There we are. Letting you see behind the curtain a little bit. All right. So this comes up with the this comes up on the assessment as one of the secure and the exceeds problems is the triangle side problems. So far, like basically if you've been following this and you've been doing pretty well with it, everything that you've done up to this point is secure. So if you've been doing everything that if you basically followed parts A through C of the review and you've been keeping up and you've been keeping up and doing just fine with it, then your grade's probably going to be secure. For parts D and E, this is what's going to get you secure plus and exceeds, starting with the triangle problems. And again, my reviews, I don't mess around. I am going to make sure that whatever the assessment throws at you, you've done more so that you are guaranteed to get a better answer than what the assessment is expecting of you. So, first part is just triangle side problems. We had one or two of these problems really early on, I think after the second assessment. And so what we have to do is we've got a perimeter and we have two sides and we basically have to find the third side. So in this case, I've got a perimeter of 3x plus 7. And let me see if I can, I just looked at the monitor. It's not looking too good here. I'm zoom in a little bit there. Alrighty, yeah, that's a little bit better. So I have got a perimeter of 3x plus 7. And then I've got sides of x plus 2 and x plus 1. What do I have to do? Well, the way that you solve these sorts of problems is you're going to add the sides up together. So x plus 2 plus x plus 1 is going to give you 2x plus 3. Now that you have 2x plus 3, you have to figure out what do I have to add. You have to figure out what do I have to add to 2x plus 3 in order to get 3x plus 7. And keep in mind, the 2x is only going to affect the x's are only going to affect the x's, and the constants are only going to affect the constants. So if this is 2x plus 3, there we go, and I need to get up to 3x plus 7, then I need to add an x, so that means that the missing side is x, plus, and then going from 3 to 7 is 4. And that's our answer. Let's do it a few more. Let's do it 9 more times. See if we can really hammer it home. So I've got sides 2x squared plus x, and then I've got x squared plus 2x plus 1. All right, so minus 1. So 2x squared plus x squared, that gives me 3x squared. X plus 2x gives me 3x, and then minus 1. And so that means, so if the perimeter is 5x squared, so that means I've got to have 2x squared, and then 3x. All right, so the 3x is taken care of. And this is minus 1, and this is minus 4. And so, well, this is minus 1, This is minus 4, so that means I've got to subtract 3. And so, yeah, there we go. And so 2x squared plus this is going to give me my perimeter. So that's how you solve for the missing side. So let's see, sides of so number 33, sides are x cubed plus x, and then 2x cubed minus x squared plus x, all right? So x cubed plus 2x cubed is 3x cubed. Then I have minus x squared, kind of uncontested if you want to call it that. And I've got x plus x is plus 2x. Okay. So I've got to end up with 4x cubed. So that means I'm going to add an x cubed over here. And I've got to have an x squared. And I have a positive x squared. So I'm going to add 2x squared here. I have plus 2x. Oh, okay. I've got plus 2x. So there's 2x right there. Plus 2x plus 2x. We're good. We're good. And then I need a 5. We don't have a 5. Now we do. Now we've got our 5. And that is our missing side. All right. So we've got our perimeter is 6x minus 1. And then the sides are 2x plus 3 and x minus 2. Again, we're just going to add up the sides. So 2x plus x, that gives me 3x. And then 3 minus 2 is plus 1. If the perimeter is 6x minus 1, then what that means is I have to go from 3x to 6x, I have to add 3x. And then to go from negative 2 to negative 1, well, to go from positive 1 to negative 1, I have to subtract 2. So there we go. All we're doing is we're adding up, again, all we're doing is we're adding up the two sides. We're adding up the two sides and we're getting this number here. And then we're looking at this number and the perimeter. And we're saying between this number that we calculated and the perimeter, what do I need to add to this in order to equal this? And so it's a relatively simple, it's a relatively rudimentary operation. It's not entirely, it's intuitive, but it's difficult to it's difficult to articulate, but it is very intuitive. All right. So so I've got the sides of 3x squared plus x, and then 2x squared plus 2x plus 1. So 3x squared plus 2x squared gives me 5x squared. Plus x plus 2x is plus 3x. And then plus 1 is unchallenged. All right. So I've got 7x squared on the perimeter, but only 5x squared here. So that means I've got to add 2x squared. Then I've got 4x on the perimeter, but only 3x here. No problem. And then I've got 1 and 1, so that's perfectly fine. That doesn't need to change. And there we are. All right. Again, so first thing we do, we're going to add up we have the perimeter, and we're going to add up the sides. So 4x plus 2 plus 3x plus 1, that's going to, so 4x plus 3x is going to be 7x. And then 2 plus 1 is going to be 3. So I got 7x plus 3, and the perimeter of 10x plus 6. Wait, there we go. So I've got to figure out what I have to add to 7x plus 3 in order to get 10x plus 6. And whatever I add, whatever I add to 7x, it's not going to affect the 3x. So I have to add some term of x in order to get 10. So 7x plus 3x equals 10x. So that's 3x. And then I've got plus 6, and then plus 3, so plus 3. So this plus this equals this. All right. Next up, we've got 2x squared plus x minus 1. I've got, so x squared, x constant, x squared, x constant. All right. So 2x squared plus 3x squared is 5x squared plus x minus 2x is minus x. Minus 1 plus 3 is plus 2. All righty. The perimeter is, give me a second here. There we are. Yeah, I just had to get some. There we are. I think that's a good. Yeah, this is a better way of visualizing it. So I have to cut. So I've got the perimeter, and I have to get this number, whatever this number is. I've got to add something to it in order to equal this number here. So 5x squared and 8x squared. The only thing I can add to 5x squared to equal 8x squared is 3x squared. Then I've got minus 3x minus x. So that's minus, so that, oh, dang it. So that gives me minus 2x. And then plus 2 here, plus 2 here. Oh, we're done. And there we go. That's the side that I need in order to get that perimeter. All right. Perimeter is 9x plus 9, whatever. I've got the sides of x plus 4 and 5x minus 2. Add them together. That gives me 6x, and then plus 4 minus 2, plus 2. I need to get a perimeter of 9x plus 9. So the perimeter is 9x plus 9. I've got 6x plus 2. Well, starting with the x's, I've got 6x, I've got 9x, so that means I have to add 3x to it. I've got plus 9, I've got plus 2, that means I've got to add 7 to this. And there we go. 3x plus 7, so that's 3x plus 7, so 3x plus 6x gives me 9x. 2 plus 7 gives me 9. We're good to go. All right, next to last one before we go to the next part. The side, I've got x squared, x constant, x squared, x constant. All right, and it's even written in the proper format, so sweet, standard format, so we're good to go. So 4x squared and 5x squared, that's 9x squared. 2x plus x is plus 3x, and then 3 plus 2 is 5. All righty. So I have to come up with some way of getting, okay. So the perimeter in this case is, don't want to reveal too much, there we go. So the perimeter in this case is 12x squared. I've got 9x squared, so I just need to add 3x squared. I've got 6x, but it's like I need 6x, but I've got 3x. So that gives me 3x. I've got 5, but I need 9. So plus 4. So 4 plus 5 gives me 9. 3x plus 3x gives me 6. And then 9x squared plus 3x squared gives me 12x squared. That's my missing side. Alrighty, for the last one, I'm going to use a little bit more space for this one. So 6x plus 1 and 4x minus 3, that gives me 10x. Plus 1 minus 3 is minus 2. And I have to come up with something that will add up to 15x minus 5. So 15 and then 10, that will give me 5x. And then negative 5 minus 2, giving me minus 3. All right. Negative 2 minus 3 minus 5. 10x plus 5x, 15x. That's the missing triangle side. So there we go. That is one part that will get you Secure Plus. Let's get that double E. And thankfully, we've already done like 10 problems on these. So I only came up with 5 of these ones. They're still pretty involved, but again, we only have to do 5 of them. again, the premise of these problems is that you have some kind of quadrilateral, and within the quadrilateral in question, you have another quadrilateral that is lighter. And I say lighter because inside the first quadrilateral is a shaded area. And then inside, like I said, the first quadrilateral is another quadrilateral that is white and not shaded in. And your goal is to find the shaded area. And the way that you do that is to find the area of the big guy and then subtract the area of the little guy. And of course, you only have access to polynomials because life is cruel. All right, so 41. Oh, we're starting out with squares. All right, so the last time we did this, I just used a separate sheet of paper, so that's what I'm going to do here. So with the outer square side, so with 41, outer square side is x plus 4, and then the inner square side is x minus 2. All right, move this over here. Let's see. All sides of binomials, find the value of x, then calculate the shaded area. Yeah, we're just going to find the value of the shaded area. So all we're going to do is we're going to find the area of the outer one and the area of the inner one, and then we're going to subtract the two. The good news is with squares, they're perfect squares because the area is equal to the length times the width. And that's going to be the same for all quadrilaterals for all squares. It's going to be the length times the width. And with squares, the length equals the width. And so if you have a square, if you know the side, then you already know the other side. And so you basically have x plus 4 for the outer one squared. And if this sends off some alarm bells, well, it shouldn't be alarm bells. I don't want you to be that nervous. It's because it's a perfect square that is equal to x squared plus 8x plus 16. Similarly, x minus 2 is also a perfect square, which is equal to x squared minus 4x minus 4. And so what we have to do now is we are so the final equals the area. So A equals, so that's what that area equals. The area of the white area equals that. So area minus area of the white area. So that's x squared minus plus 8x plus 16 minus x squared minus 4x minus 4 equals, and now it's just a subtraction operation. Now it's just a polynomial subtraction operation. So I've got x squared minus x squared, those cancel out. 8x minus negative 4x, that gives me 12x. And then 16 minus negative 4 gives me 20. So that's your area. That is the area of the shaded region. And there we go. So that's if we're working with two squares. What if we're working with something other than a square, which is, I mean, we're literally only going to be working with a rectangle or a square. So let's work with an outer rectangle. So for problem 42, as you read this, I'm going to read it out loud and then draw it on my paper here. So the outer rectangle is equal to x plus 2 on the length, and then the width is x plus 5. I am not drawing this to scale, by the way. And then the inner width of the square is going to be x minus 1. All right. So going here, and like I said, I am not drawing this to scale at all. So the first things first, I'm going to figure out what the area of the inside is because, frankly, that's the easiest one. because it's basically just the product of, it's a perfect square again, because it's x minus 1 squared, which is equal to x squared minus 2x plus 1. So that's the area of the inside. The area of the outside is a little bit trickier because that one is going to be just kind of like how with the square, the area of the quadrilateral is equal to the length times the width is equal to the side times the side. With the square, the sides are all equal. With any other quadrilateral, you have to multiply the length times the width. And so in this case, that's why we're given two different numbers here. So in this case, the area of the rectangle is equal to x times 2 times x plus 2 times x plus 5. And there are a couple of different ways we could go about doing this, but the fastest, cleanest way, I think, is just going to be the FOIL method. So I'm going to go with the first ones. X squared outside gives me 5x. Inside gives me 2x. And then last gives me 10. So that's x squared. There we go. That's x squared plus 7x plus 10. Okay. Now, for the final area, we have on screen now, we have our outside area minus the area of the white region inside. So that's x squared plus 7x plus 10 minus x squared minus 2x plus 1. All right, so the x squared, I've got x squared, that cancels out. 7x minus negative 2x, that's plus 9x. Then 10 minus 1 is 9. So there we go. That is our area. So that's 9x plus 9. Alrighty. So we'll go on to 43. So for 43, oh, I've got double squares again. Oh, those are nice. I like those because they are very easy to calculate. Because like I said, they're just two perfect squares. So the outer one is 2x plus 1, and then the inner one is x plus 3. Even though the outer one is 2x plus 1, it's still, the perfect square thing is still really a very handy thing to have access to. So let's start with the first area. It's going to be 2x plus 1 squared. And again, with the perfect squares, it's going to be x squared times 2ax plus a squared. So that's going to be 4x squared plus 2 times a, 2 times a, which is 1, times x, which is 2. So that's 4x plus a squared, which is 1. So that's our outside area. We're in pretty good shape there. The area on the inside is going to equal x plus 3 squared, which is going to be x squared plus 6x plus 3. All right. Yeah, we're doing great. So the final is going to equal the area minus the area of the white space, which is 4x squared plus 4x plus 1 minus, and then x squared plus 6x plus 3. Make sure that when you're subtracting the area of the white space that you put this all in parentheses, because you're subtracting the whole quantity. You're not subtracting just x squared and then adding 6x and 3. You're subtracting this whole unit, this whole object, which is represented by this quantity. Plus, if you mess up the signs, it's going to mess up your answer and mess up your final calculation. So 4x squared minus x squared, that gives me 3x squared. 4x minus 6x is minus 2x. And then 1 minus 3 is minus 2. And there we go. The answer is 3x squared minus 2x minus 2. Alrighty. Problem number 44. And I see number 45 is square, so we're ending on a high note. So I'm pretty happy about that. So the next one is another rectangle. So the outer one is going to be x plus 6, and the width is going to be x minus 1, and then the inner square is going to be x minus 4. And I clearly missed some formatting issues with that one, but que sera, they've already been ordered. Alrighty. So again, we've got these ones here. So yeah, I'll just go ahead. There's the area. I'm just going to go find the area of the white space. So that's equal to x minus 4 squared, which is equal to x squared minus 8x minus 16. So there we go. I mean, that's the first area just completely done. The second one is going to be x plus 6 times x minus 1. And just like before, I think that if you have something simple like this, the best way that you can do it is to use the FOIL method. So I'm going to do first, which is x squared, outside, which is x minus 1, so that's minus x, inside, which is plus 6x, and then last, which is minus 6. So combine like terms, that gives me x squared plus 5x minus 6. All right. So for our final, we have a minus aw, which equals x squared plus 5x minus 6 minus x squared minus 8x minus 16. So x squared minus x squared, there we go. Now we're all in frame. X squared minus x squared, those are going to cancel out. 5 minus negative 8 is the same as 5 plus 8, so that's going to equal 13x. And then negative 6 minus negative 16 is the same as negative 6 plus 16, so that's going to be 10. And there we go, 13x plus 10. There we go. You should be getting to be pros at this by now. I would certainly hope so, or at the very least exhausted of my reviews. So 45. This is the last one before the assessment, the last problem before the assessment, before Christmas break too. All right, so we have an outer square. Oh, I knew that it was coming, but I'm still very happy to see that it was a square. So x plus 7 on the outside, x minus 2 on the inside. All right. All right, let's see. So the outer area is going to be x plus 7 squared. And that one's just going to be x squared plus 14x plus 49. The inner area is going to be x minus 2 squared. So that's going to be equal to x squared minus 4x minus 4. And so, I mean, again, this is why those perfect squares are so powerful, and why those products and products of squares and difference of squares things are so powerful. I just see x plus 7 squared, and I know what it simplifies out to. I see x minus 2, and I know what it simplifies out to. Makes recording videos a lot more time effective. Let's see. I've got final equals a minus aw, which equals x squared plus 14x plus 49 minus x squared minus 4x minus 4. Should be plus 4. Talked a big game, and then I forgot it was plus 4. So x squared minus x squared, those go away. 14x minus negative 4x, that comes 18x. 49 minus 4 is 45. So 18x plus 45. All right, that is it. That is the final review of the unit. And what that means is that the very next thing that you're going to be sitting down to doing in this class and in this unit is going to be the assessment, assessment number 3. So I know you can do it. I know you'll do great with it. Because if you made it through the review, the assessment has absolutely nothing on you. So yeah, I'll see you there.